Texting while driving. What's the safer route? Interstate or city streets? Statistical analysis by Devin Wyatt.
Dixie Ball.
Ronnie Morris.
And Stephen Warner.
Let's be honest. Have any of you ever sent a text message or typed on your phone while driving? I won't hold this against you. For all those who raised their hands, I was lying to you. This presentation is for you. Because there's lies, damn lies, and then there's statistics.
So, we've had a premonition. Can you name this movie? After a young man's premonition of a deadly race car crash, he helps save the lives of his peers, but then death sets out to collect the lives of those who evaded their end. You guessed it. So be careful out there. Your unintended destination could easily become your final destination when you text and drive. Texting while driving is a growing trend and a national epidemic, quickly becoming one of our nation's top killers. Since 2007, 46 states, including Louisiana, have actually passed a texting ban.
In the state of Louisiana, the use of certain wireless telecom devices for text messaging and social networking is prohibited. The first offense is subject to a $175 fine. Subsequent offenses are subject to $500 fines. It's a primary offense, and it's a moving violation.
According to the National Highway and Safety Administration, texting while driving makes you 23 times more likely to cause a crash. They also claim that you're about 6 times more likely to cause an accident texting than driving intoxicated. The Virginia Tech Transportation Institute says that texting while driving is the same as driving blind for 5 seconds at a time.
Baton Rouge is a unique city that has 2 interstates running through it. Every day, everyone faces a dilemma. Do I take the interstate or do I take a city street? So you must also ask yourself now, as far as safety goes, do people text and drive more on interstates or city streets? What's the safest route?
For our case study, we chose the route from Highland Road to Acadian Thruway. We surveyed drivers on both the interstate and Perkins Road. Our 2 populations were people driving on the interstate and people driving on city streets. Our hypothesis was a higher proportion of people texting and driving on the interstate than city streets. Our variable of interest was the proportion of people who text while driving, and our sample size was 863 people driving vehicles on the interstate and city streets.
Here's the table of results from our survey. So we conducted our survey on a Tuesday and Wednesday from 10:30 a.m. to 11:30 a.m. The criteria that we used to identify a texting driver was that the vehicle was in motion and the driver was visibly operating a handheld device. As you can see, we observed 30 interstate texters out of a total of 236 observations and 38 city street texters out of a total of 627 observations. In total, we observed 863 drivers.
Now let's take a closer look at statistical inferences. The point estimate for the confidence interval of the difference between the proportion of texters on the interstate and city streets is calculated as P-bar1 minus P-bar2, which are the sample proportions of interstate and city texters respectively. The margin of error with 95% confidence is shown to be 4.64%. This means if we went and did the survey again, we could expect the difference to fall in the range of 2.01% to 11.29%.
We tested 3 alternate hypotheses. The first one was that the population proportion of texters on the interstate and city streets are not the same. As you can see, the null hypothesis is pi I minus pi c equals 0. The alternate hypothesis is pi I minus pi c is not equal to 0. The z-star test statistic is calculated to be 3.23, which is shown as being outside the fences of the null hypothesis. For that reason, we reject the null and accept our alternate hypothesis. The second hypothesis was that the proportion of the texters on the interstate is greater than that of the city streets. In this circumstance, the null hypothesis is calculated as pi I minus pi c is less than or equal to 0, and the alternate hypothesis is pi I minus pi c is greater than 0. The z-star test statistic is calculated as 3.23, and per the graph you can see that it sits outside the fence of the null hypothesis. For this reason, we reject the null and accept our alternate hypothesis. The third and final hypothesis is that the population proportion of the interstate texters is 2% greater than that of the city texters. The null hypothesis is calculated as pi I minus pi c is less than or equal to 0.02. The alternate hypothesis is calculated as pi I minus pi c is greater than 2. The z-star test statistic is calculated to be 1.96. This sits outside the fence of the null hypothesis as shown in the graph, which means that we would reject the null hypothesis and accept the alternate hypothesis.
Our sample data supports our hypothesis and shows that the proportion of interstate texters is at least 2% more than city texters. Therefore, based on our statistical analysis, we can conclude that Baton Rouge city streets are the safer traveling route.
After completing our case study, we recognized several limitations. Our sample time was limited to 10:30 a.m. to 11:30 a.m. with non-rush hour traffic. It was on a Tuesday and Wednesday, and there was limited student population. Our observation route was Acadian Thruway through Highland Road, and we did not consider isolated interstate highways, rural roads, and it was limited to Baton Rouge.
Texting while driving.
It can wait.